Okay, to make the video very short, I'm going to just to explain very fast what is going on. The line integral of a vector field is just the vector dot ddr. So it's f of x ddx plus f of y ddy. If you do the dot vector in textbook, they write it like this: m of xy. Well, m is f of x. This is a vector field. M is the component, is the x component of the vector field, and n is the y component of the vector field. The Green theorem say that the line integral over a curve is an amazing theorem. Is the line integral over a curve is equal to a double integral. The double integral over the region R. The region R is the region that is inside the curve. So it's impressive how, knowing about the boundary, you can know about the inside. Okay, so we use a particular vector field. This is the vector field that we need to use, because we need here one. To represent area, we need a 1. So we use this vector field minus yi plus xj, because if you do the partial derivative of m respect to the y is minus 1, the partial of n respect to the x is 1, so it will be 1 minus 1, it will be 2. So dividing this 1/2, the area will be 1/2 of x, the x, f scalar ddr, f scalar ddr will be 1/2 of x ddy minus y ddx, x ddy minus y ddx. So if we apply this equation, we find the area inside. So the second step is to do this integral for a line. If you do this integral for a line, meaning this is x1, y1, x2, y2, if you do this integral for this line, remember that this line is y equal y1 plus m by x minus x1. Doing this integral, and so dy is m by ddx. Then if you do this integral, placing dy like m ddx and doing the integral from x1 to x2, dy depends on ddx. So from x1 to x2, the integral is easy to do it. The integral will be y1 multiplied by x2 minus x1 multiplied by y2. This is the integral with the 1/2. So now we apply this equation. This is the area. Area, when you sum it to all the points, you sum it to all points. This is the area. Okay, this is the area inside if you sum it. But you have to sum in the counterclockwise direction to make possible that the Green theorem will work. Okay, let's go to do it with the example that we have. Okay, here I did the calculation. You can check the calculation is 1/2 y2 minus x1 minus y1 multiplied by x2. So let's go to apply to this problem. Now I check my equation to one triangle. Okay, the triangle is being you make all the calculation from on counterclockwise like this. Okay, and I did A B, BC, and CA. I did the calculation, it happened to me, but let's go to do it with your in the area. Well, so this is the example. Let's go to find the area of the first figure. So the figure, it has 3 points, the A, the B, no, let me put it like this. The A, the B, and the C. And I'm going to perform the line integral in this direction. But I know that the area is 1/2, is the summation when I sum. 1/2 y2 x1 y2 minus y1 x2. This is the formula. And I have to make the sum for all the points. In our case, A is the point 1, 2, 3, 4, 5, 6, 6,0. B is the point 1, 2, 3, 3, 3, 1, 2, 3, 4, 5, 3,5. And the point C is the point 0,3. And I want to find the area by making the sum of all this. So what is AB? In going from AB, I perform a sum. And the sum will be 1/2 x1, 6. x1, the x1, y1. The x2, y2. The x3, y3. So it will be x1, y2, 6 by 5, 30. Minus x2, y1. x2 is 3 by 0 is 0, 0. So here is 15, AB. Now BC. BC, it will be 1/2. Now BC, it will be x1, 3 by y2, 3 by 3, 9. Minus x, the second component, 0 by 5, 0. So it's 1/2 of 9. BC. And now CA. CA will be, so CA, this is x1, y1. And this is x2, y2 now. So C1 will be x1, 0 by something 0, minus x2, x2 is 6 by 3, 18. 1/2 of 18, or 9. And what is the area? Here is minus 9 because the formula is a minus. Here is this minus x2 multiplied by y1. y1 is 3 and x2 is 6 is minus 18. Here is minus 1/2 of 18, which is minus 9. So what is the area? The area is the summation of all this calculation. 15 plus 9 divided by 2 plus minus 9. So we can sum here. Sum will be 30 divided by 2 plus 9 divided by 2 minus 18 divided by 2. So the sum will be 39 minus 18 divided by 2. And 18 by 18 is 36, so it's 18 plus 3 is 21 divided by 2. So this is the area. You can check that I'm not wrong. This is the exact area. Wow. Good. I hope you like this way. If you need to review the calculation of the line integral for the vector field that gives the vector field who works good for the double integral, it means that the derivative of m respect to the derivative of n respect to the y minus the derivative of m respect to the x is 1. If you can do the integral, you can see what I did. It's working. It's good. It's incredible good.